Hello everyone, I hope y'all are doing great. So today the topic that we're gonna study is all about magnet. What is magnet? Today we'll discover this thing. Very first, you might have seen this thing in maybe cartoons or in maybe real life as well. This thing is known as a magnet. Now, in might be in real life, this is the man-made and actually designed magnet, but in reality, magnet is found in sort of rocky thing. It can be of steelish color or silverish color, and sometimes it's of the rock color as well. Now, what is exactly a magnet? An object? Yes, magnet is an object that has the property to repel, and attract metals. Now, this line is a very important and basic definition of magnet, that whenever an object or maybe a stone that is attracting or repelling metals is known as magnet. Now, why I'm using the word metals only? Doesn't it work for the non-metals? Yes, it doesn't work for the non-metals. Probably the metals are good conductor in terms of electricity as well, good conductor in terms of the capacity as well. So magnet actually works on the basis of the things that can conduct electricity, and most probably only metals can conduct electricity. Well, there are exceptions in metal as well. Those metals whom are weak conductor, sometimes magnet doesn't work for that as well, and the best example can be boost. But most of the metals are attracted by the magnet. I hope that you are clear with the basic definition of magnet. Now let's delve into the discovery of magnet. So the first magnet that was discovered in this world was lodestone. Lodestone, as you can see here, is basically a mineral and a stone that was found by which a lot of nails got attached. Now you know nails are made up of metals. That's why they got attached with that specific um, magnet. Well, there is a concept of permanent and temporary metal. The lodestone that was founded, it was in permanent magnet. Permanent magnet doesn't lose its properties of magnetism, but temporary one lose its property. Well, it's a huge topic that I'll cover in any other video. But for now, just keep this in mind that an permanent magnet doesn't lose its magnetism, and the first discovery with lodestone, that was an permanent magnet. Okay, now let's move on to the depth of the attraction and repulsion concept. For that, I need to just zoom out. Here you could see an sort of thing. Maybe I forgot to give you a concept of one thing. That just suppose that this is a stone that is magnet. Now at very first, whenever you're talking about a magnet, magnets always have two poles. Now what term I'm using? It's poles. Or what in charges we do have terminals, right? So here the terminal word is replaced with poles, and in terminal we do have positive, negative, and this poles we do have positive as nitrogen, oh not nitrogen, sorry, north and south. Now north is the what you can say, the positive sign which has these more potential within it, and the south is negative sign which has least potential within it. And whenever you are talking about north and south, so as you can see here in the figure, all the magnetic waves or all the magnetic lines that are actually showcasing the magnetic field. Again, magnetic field, magnetic force, magnetic line, these things will be covered in next videos, but for now just keep this in mind that these are the temporary lines, invisible lines that shows us the direction of the movement of the magnetic field that I have actually stated that what is magnet? Magnet is attraction or repulsion between the metal and the magnets, right? So here, when we are talking about repulsion or the attraction, so in word terms, what are the lines that are attracting that thing, or what is the area in between which the line is attracting itself? Well, when we'll rotate this picture, it will become a happy face. So happy face for you all. By the way, okay, let's get back to the point. So this area is known as magnetic field, and these lines actually shows us the direction from where to where things are getting attracted. Because when we are talking about the attraction, so it will be sort of like, okay, these lines are moving towards this thing. But when we are talking about repulsion, so it's a great concept that lines are getting backward. Why they are getting backward, now this is again a question, but for now just keep this in mind that the line always moved from north to south. This thing you might find really unusual, but just take north as positive and negative as south. So in this situation, in magnetic field, the positive is moving towards the negative. Now probably positive is not itself moving towards negative, but it's creating a sort of attraction within it, that this negative is just attached to this positive. One more concept in magnetic thing is that, just suppose that this is a magnetic bar and this is the north pole, this is the south pole. What if I cut down the north pole and south pole into two objects? Like, just suppose that this is the north pole side, I am cutting this thing out and making this north and making this south. I have actually cut it in two pieces. Now, will it still be only north and south, and will they attract each other again and just get into each other and get attracted? So if you're thinking so you guys are wrong. Whenever a magnet is actually broken down or is splashed into many of the particles, they again make their own north and south pole within that piece as well. Just suppose that I'm again breaking it down into two pieces. This would be north and this would be south. So again it will create its own pole by itself. It will be again north and this will become south. So this concept is really important. Now in this situation, the main reason a lot of time is stated that just because the north pole and south were attached to each other, that's why they create this sort of process that the north pole magnetic field is moving towards the south pole one. Now it will be easier for us to understand the attraction and repulsion. Whenever there are alike not let's just start a study with the non-like. So just suppose for a while, here is the north pole, here is the south pole. Now let me complete this bar. This is the south one and this is the north one. Now here, if you could see the lines more clearly, so here in this specific bar, the lines are getting inward to the south pole, but here the lines are getting outward from the south pole. Now this, what does this shows? This shows that movement of particular, just leave this side first and just consider this as a full bar. So here you could actually imagine the movement of the south and north. Now getting back to this bar, that how it is created. Okay, let me remove this line. Now we all know that whenever there are opposite poles, there are opposite poles in a single magnet as well. So they create in sort of lines that create a magnetic field within them. So when the opposite pole comes together to another opposite pole, they attract each other. Now what will basically happen? This north pole and south pole will get attached to each other. Again, now what will happen? This will become fully north pole and this will become fully south pole. And after attaching down to each other, they will become a single bar in which this would be north and this would be south. In another case of when both of the poles are similar to each other, what will happen? They will repel each other. They will actually throw back each other, by resulting in which they won't be able to get indulged into it in cell, and they won't be in full magnet terms. In situation of the north and north, same happens. They repel each other. Okay, so this was it for today. I hope that you get the whole lecture and got the clear concept of magnets, magnetic lines, and fields. Well, thank you so much for watching. Stay tuned.